Welcome back, everyone. I hope you all had a great lunch. That was a good lunch, wasn't it? That was really, really good. So I know we have quite a few healthcare systems represented here and also quite a few pharmaceutical companies. So I had this idea for these two groups. You know how every single medication comes with a long list of possible side effects? What if you just put a QR code on the side of every medicine, and then the patient scans the QR code and they hear a song about the side effects? Now think how efficient that would be. Because in most cases, it's a super list of side effects, right? It's a super list. It's a super list of side effects from your brand new prescription. Rather than a written sheet, we'll sing you the description. Hopefully this won't scare you and then give you a conniption. Super list of side effects from your brand new prescription. This drug may cause drowsiness, skin rash or palpitation, diarrhea, kidney failure, and hallucination, dry mouth and insomnia, fatigue and constipation, dizziness and stomach aches and increased urination, vomiting and nausea, advanced short-term recollection, weight loss and blood pressure that head in the wrong direction, weakness and blurred vision that seems like it needs correction, increased thirst and muscle stiffness and sinus infection, seizures and confusion and loose stools and salivation, allergic reaction and perhaps your expiration. But despite these side effects, no need for hesitation. Your doctor still thinks that it's fine to take this medication. So let's put that on the side of medicines. That would work. All right. Everybody's warmed up. Now to kick off our afternoon, please help me welcome to the stage Merav Bahat, Mike Towers, and Bob Durfee.
I picked the song.
That's going to be tough to follow.
Good afternoon, everyone. Really happy to be here on the stage with Mike Towers and Bob Durfee, who've been our design partners and some of the leaning forward CISOs and technologists around cyber. So thank you for that. We'll start with a quick introduction. Mike, would you go first?
Sure. Mike Towers, Chief Digital Trust Officer for Takeda, and I've also been on the board of Health ISAC, now going on my 7th year.
Bob Durfee, Head of Digital Enablement and DevSecOps at Takeda.
And Merav Bahat, co-founder CEO at Jazz. Before starting the company, I was General Manager of Cloud Security at Microsoft. So probably some of you know some of the products that we build there. What we do at Jazz is actually, most companies on cloud security focused on detections and showing you what's wrong. You really focused on orchestration, remediation, and helping you with the fix. So let's start. Mike, if you can, quickly kind of give us some overview of Takeda and the mission.
Yeah, sure. So Takeda is a very values-driven, research-based biopharmaceutical company. We're officially headquartered in Tokyo, and most of our US operations as well as R&D is run out of Boston, where I'm based. We're primarily focused on 4 therapeutic areas: oncology, GI, gastrointestinal, neuroscience, and rare diseases. And we tend to do that over a number of different modalities, everything from small molecule to large molecule. And we also have modality specialization in vaccines, and one of the more unique areas of our business is plasma-derived therapies. We'll talk about that a little bit later from a example perspective. And the only other thing I would say about Takeda is that we have a very deeply embedded value system around putting the patient first. And our value system is 4 simple words: patient, trust, reputation, and business. That order is important because that's the priority order of the company. And the trust word, which is second, is obviously pretty important to me because it's now my title.
And can you share with us, the cloud innovation? I know you're one of the first pharmaceutical companies to actually move to the cloud, adopt new tech. And if you can also give us an example of one of the applications that moved there and, what's the value?
Sure. So our CEO and Takeda overall is quite progressive, that he wants to transition Takeda to be one of, if not the most tech-driven biopharmaceutical companies. So data, digital, and technology being completely rewiring how the company operates. I think broadly speaking, we've talked about it a couple times. The industry is ripe for innovation. It needs to be more data and digitally driven, and we're trying to do that from a Takeda perspective. And part of being data and digitally driven, you have to be cloud-based. I mean, you can't deal with the scale, speed, frankly, the compliance or security requirements without being cloud-based. So we have a very, very aggressive cloud transformation program that started about 18 months ago, and we probably have another 12 months left in terms of the big initial program, but it's going to be our ongoing platform of the future. And cloud starts with things like moving your apps out of your data centers, but it's a lot more important than that. We are closing 14 data centers as part of this program, but when you really leverage cloud, you're talking about moving to a more agile, product-based methodology. You're talking about a lot of more expectations of speed. If you truly adopt DevOps, you have to start thinking about people developing code, also being the people who support the code. And as part of that transformation at Takeda, we've had a lot of fragmentation. There's been dribs and drabs, there's been Jenkins, there's been other pieces that have, and different, I would say, pipeline capabilities that have built up. And it was quite fractured and quite variable. And we wanted to build an environment that, rather than forcing people to use it, we wanted people to want to use it, and building the best DevSecOps pipeline we could, which Bob will talk about a little bit later. But one of those areas that we wanted to make sure was that it was easy to use and it was really, really development and app development centric. And one of the examples that I'll talk through is, I mentioned our plasma business. We have an application, it's called the plasma chain. And if anybody has children or if anybody themselves has donated plasma, you have a right to know, and frankly, you're regulated to know how your plasma chain of custody goes through the donation of plasma, the fractionation, the refinement, and then how it's given as a treatment. And that application tracks all of that from a chain perspective. And that application was one of the first to go through this new pipeline, DevSecOps pipeline that we'll talk about. And as a pretty good indicator of success and something that we often use to help entice others, the end of the process where that application was penetration tested had absolutely zero issues, which was the first time we had an application go through this cloud native process with zero issues. By comparison, we had a couple that went through some of those older, more fragmented processes, and they were getting some of the lowest scores some of our partners have ever seen. So we've already seen some definite advantages of doing this in a more structured but flexible way.
So obviously there are tons of value to moving to the cloud, but so how do you prepare yourself from the security perspective? So Bob, what's the toolkit that you prepared and the processes to enable to support that transformation?
That's a good question. Well, as Mike mentioned, we have these fragmented, and I'll call them really app-driven based pipelines. We had, for example, R&D. They're all using the Atlassian suite. We had the commercial teams using Azure DevOps. And those really, although those could scale for us, they couldn't be managed by those teams. We didn't have anything really enterprise ready. So when we began this initiative, we said we need to build a platform that can not only scale, but can be managed by our team and be, I would call it cloud ready. We want to make sure that we have infrastructure as code. And a lot of people are probably asking, why do you have a DevSecOps guy talking about cloud security? And the one word that comes to my head is code, or 3 words would be infrastructure as code. If you need a VM, that's code. If you need storage, that's code. If you need network, that's code. If you can put that infrastructure all into a code format, then you can do things like automate, you can scan, you can do these things that you really don't have visibility to when you do it. I call it in a console-based deployment, and that it doesn't scale. It might be fine for 1 or 2 servers, but if I'm trying to deploy 100 or 1,000 servers, it doesn't scale like that. So our pipeline really consists of let's get a suite of tools. We use GitHub as an example as our source code repository, and a suite of tools, and I'll call it a traditional code scanning, static application security testing model. We have API testing. We have, we scan our artifact repository. And then we went through the classic, all right, once you find a defect, once you find a vulnerability, how do you reach out to people? Okay, well, classic, let's send them an email. Let's open up a Teams meeting. Let's send them an Excel spreadsheet, as an example. And occasionally we'd use Jira, but some of the teams hadn't adopted Jira yet, so we had to have those other models. And then the ultimate, the right-hand side of that is fix it. How do you fix it? Well, if it's something that's not in our pipelines, you have to go to AWS and remediate it that way. But the ideal solution is to fix it in the code, fix your infrastructure as code, redeploy, and update where you can. And there's some things you can update via code. There's some things you can't. And we can probably talk about that in just a few minutes.
So it looks like you invested in a lot of tooling and probably spent a lot of money. And then the remediation process was kind of manual still. But did you feel that you get it all right? Did you feel that you were secure?
I feel secure. Well, we spent enough money. Yeah, I feel very secure. But in all honesty, if we look back at it, did we do things right? I think we did. But we had knowledge. We knew deep down that this probably wouldn't scale when we start getting a large number of repositories, and we were proven right. So we had knowledge. Now we have wisdom. And what happened was we had nothing in this environment in 2019. We had 0 repositories. As of right now, we have over 3,000. And how do you mitigate that? How do you manage all those alerts for 3,000 repos? And sending an email is not going to work. Calling somebody up via a Teams meeting is not going to work. And so and we also have all the disparate platforms that are sending these alerts. We have the gamut. We have the Prismas, we have the Wiz, we have Salt, we have static application security testing, we have Dependabot, all these things, and we have to dig down and get all that information, and it's hard when it's all spread out like that you have to address.
Interesting. So, how long did it take you to get into from 0 alerting into how many were there?
Just recently we did a check, and we get millions of alerts. And as a recent example, about some of the noise we get, Mike was looking for some metrics for, how are we doing? How many vulnerabilities do we have? How many resolved? And so I reached out to one of the guys on my team and said, basically asked the same question. How many Prisma alerts did we get? And he comes back and gets 2.4 million. 2.4 million, okay, well, that's a lot. Okay, you have my attention. And how many did we remediate? 2.3 something million. I'm like, okay. And what's kind of the scary part is the 2.4 million didn't bother me. I'm like, how did we remediate 2.3 million? That's the part that made me nervous. And then it turns out, after doing some digging, is the R&D team had built a platform where they're spinning up hundreds of servers, spinning them up, doing some compute. Turns out they're spinning them up without, okay, I'm going to use some AWS terminology here. Their volumes, their EBS volumes, were unencrypted. And we have a security policy that says all data must be encrypted at rest and in transit. And so we had some EBS volumes get spun up. Okay, alerts, they come flying. They get torn down when they're done processing. Hey, you resolved all these, we remediated this problem. So we had, okay, problem, no problem, no problem, multiple times per day, 365 days a year. That's just noise. Okay, so it's something that we had to deal with and something that we had to address.
So this is around the time where we all met. And kind of interestingly enough, we worked on some kind of framework, right, to for you to change the process and have a better, solid process. Can you walk us through a little bit about what the guidelines in orchestration and remediation of cloud security issues?
Absolutely. Well, if you look at this blueprint, it's somewhat, I'll call it vendor agnostic. Really, you need to take inventory of what you have from a platform and pipeline basis. Okay, what tools do you have? What alerts are you getting? Okay, Wiz, Prisma, API scanning, static application security testing, and we also have tools that scan our infrastructure as code. Are you about to create an S3 bucket that's unencrypted? Are you about to have deploy a KMS key is exposed to the internet. Those types of things that we can scan and code. So we discover those things and we determine what alerts we're going to get. So we analyze that. We look at deduplication. For example, that up and down I was talking about. Really, that's not 2 million issues. That's 100 issues happening 200,000 times. Am I doing math right? I'm not sure. But regardless, it helps us determine, okay, what's the root cause? The root cause of those 2 million issues is really 100 servers. And then what do you do to remediate? Okay, you have to find the owner. Okay, where is the owner? Oh, okay, I know somebody in R&D who's responsible for AWS. All right, let's start with him. And then you're making phone calls or emails, and then you have to track that person down. And then you have to reach out to the person that's responsible for, if they're using Terraform or CloudFormation, go remediate that issue so that going forward, when you spin these things up, they're going to be safe. And then ultimately, prevent. And it's very similar. In this case, you spin something up and you tear it down, you don't have to worry about how to remediate it as much as you do prevention. Because if you look at it, there's a phrase called pets versus cattle. A lot of people have pets. These are the servers that we spun up and we take care of them. We patch them manually. We rub their ears, do all those things. And then you have cattle. Okay, we need to spin up 100 compute instances. When we're done, shoot them. We're done. We don't care. So, sorry to any cattle fans we have. But ultimately, those pets you have to remediate. The cattle you can prevent.
Interesting concept. So if you can share with us a little bit about how it was deployed in your environment, and if you can also give an example, maybe Log4Shell, how did you work with that system?
Yeah, so what we did, we utilized DAS to help us get our arms around this process. So if you notice, it's really I don't want to drain this slide and say, all right, we're using GitHub, we're using Salt, we're using Shift Left, and blah, 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 which I guess I'm doing right now. But the crux of this is we had a capability to map that pipeline. We have a tool to help us do that. We have, the key for us was to help us get rid of that noise, deduplicate. Okay, look at Wiz, for example. Wiz is telling us we have 80 machines that have no EBS volume encryption. But guess what? They were all created by this CloudFormation template that's sitting in this GitHub repo. That was owned, and the latest commit was done by John Doe. So we can now go right to John Doe, fix your CloudFormation template, set EBS encryption to true, or however you're going to do it, and then redeploy. Well, I got to be careful when I say redeploy. Doing an EBS encryption fix in AWS is not just redeploy your template. It's really you have to tear it down the volume and recreate it. But what that does, though, is shows the power of prevention versus remediation. If we caught that issue in your CloudFormation template, hey, you're about to create an EC2 instance that has an unencrypted EBS volume, we'll catch that. If you can do it in the prevention time, that's a 1-minute fix. If you have 50 servers, that's a 30-minute fix. That's 25 hours. I'm pretty sure of my math on that one. So with Log4Shell or Log4j, what we like to call the holiday ruiner for a lot of folks in the room, it helped us determine where was the source of the issue. Okay, we have these platforms that will say, all right, yes, these machines have Log4j on them. Great. All right. Well, how did it get there? Is it deployed via a COTS application? Is it part of an appliance? Is it some code that we deployed? So it helped us determine that X number of machines was a COTS application. X number of machines were done via an application set of code. And then what happened is it consumes Dependabot, which was pretty helpful in telling us you have these plugins, or excuse me, components that are vulnerable. So we were able to go out and we aren't draconian too much on the DevSecOps side. We're pretty lax about it. But when we came to Log4j, we said you've got 48 hours to merge this into your code, or we're going to merge it for you. You don't have to deploy. Okay, we're not going to force you to deploy, but at least from a dev perspective, you have to have this code merged, committed, merged, and pushed to dev. And then you can work on deploy. I mean, we have a number of apps that are qualified and software bill of materials that have to be updated, so forth, and we just can't force that deployment.
And interesting. So, and a question is, so you're talking a lot about dev. So, do you think that now your relationship with dev are better, worse? I mean,
our relationship with dev is actually quite good now. We do things like, for example, we created some chatbots that allow them to create their own repos. So we made it developer friendly. You want to use our platform, come on in, the door's open. We don't gatekeep and say that GitHub's better than Bitbucket or anything like that. We want to make a product that people want to use. And then the developers are much more amenable to having this view that they can look at and go, all right, these are the critical vulnerabilities we need to find. Plus, we don't have to have a PM go dive into GitHub repositories and look at Dependabot notifications to say, we need to fix this in the next sprint. We can talk to Jira, create a ticket, put it in the backlog, and then the PMs can take care of it themselves. So it really helps our devs from that perspective.
Great. So can you share some of the results? Can you summarize the result of this experience? By the way, how long did it take you to build this?
I think we had this stood up. We had DAS stood up in about a week, and it connected to GitHub, which was actually it looks at repo scanning. We had it connected within a couple of days. Wiz in a couple of days. Priz, I mean, soup to nuts. We had this thing spun up in about 2 weeks. So that being said, what it really does for us is we get all the information from all these disparate systems, and we have a single view. So we can go in and go, these are our critical vulnerabilities that we need to worry about. 5 of these are coming from shift left, 3 of these are coming from Dependabot, 5 of these are coming from Wiz, and then X number are coming from Prisma. So I don't have to go out to each one of these platforms and have it alert me or get an email and sift through it or sift through a spreadsheet. So I can just go out and focus on really what needs to be focused on. So what that's really done as a result of that is also, I think I might have mentioned this, it can help us find, okay, this vulnerability is coming from Wiz. Wiz detected it. It was created as part of this Terraform module or CloudFormation template. We could track down that owner. It was committed by John Doe, and it's immediate. We know who to contact. So it really helps us in the deployment phase and in the correction or remediation phase. So what that's all done is shorten our mean time to resolution. From the time we find a vulnerability to the time we can correct it is probably cut in half. And then what that's done is that from a cloud security perspective, we now have all of our policies. We put all our policies in, you put them in Wiz, you put them in Prisma, you do compliance checks. We also codify that. It's all in code. We now check with various tools that we use to scan and say, all right, you're going to deploy this KMS key, or you're going to have an unencrypted EBS volume. Having your infrastructure in code is key to making this all work, and it does make this sustainable. If we have 3,000 repos, it can't be done on a manual basis where you're pop over here, pop over there, scroll through an Excel spreadsheet. It just doesn't work that way.
Right. So, just in terms of any advice for security, I mean, we have many security people here, practitioners, CISOs. So we start with you, Bob, on what should be the takeaway?
Okay. Well, if you're beginning your journey to the cloud, if you're just heading there, code. Just do everything you can in code. I know it's unrealistic. You can't do everything in code. You're going to have some console-based access. So that's why you need both ends of it. You need your code scanning in your repositories to catch things before they happen, and then you need the tools such as Wiz and such as Prisma to catch things after deployment. Because not only you can deploy stuff via code, and then you get what's called drift. Somebody goes to the console, makes a change. All right, I'm going to remove the KMS key from my S3 bucket for whatever reason. That happens. Things happen. You need to catch that. And so those tools that are post-deployment really help with that. And then you really want to catch it on the pre-deployment side. And that leads me to my second point. My second point is if you think about prevention here and then remediation over here, it's a slider. Okay, and that slider is friction. pain that you're dealing with, if you can catch those vulnerabilities or catch that policy issues that you're running into on the prevention side, as I mentioned, if you try to correct an EBS volume issue in AWS post-deployment, it's much, much harder than checking a box and saying, all right, yes, I'm going to encrypt this EBS volume. So, prevention, an ounce of prevention is worth a pound of cure. That is literally the case for cloud security.
So just to summarize, it's like do everything in code and then have a slider or prevention remediation.
Yes, build a slider.
But get it quicker
Yes.
into the prevention, I guess.
Yeah, the key is code. Everything you can put in code, whether if you're in Azure and you use an ARM or Terraform, or you're an AWS shop, you're using CloudFormation or Terraform, do as much as you possibly can in code. That's the key point to take away from this, because the remediation is much more difficult post-deployment than it is pre-deployment.
Mm-hmm. Mike, any advice?
Yeah, it's a great discussion. I think, well, first and foremost, one of the most important assets in any security leader's mission is people. So find somebody run DevSecOps that knows how a developer thinks. So that's tip one. I think tip two would be you're going to have to coach your stakeholders in your company to swing the pendulum back to being in the application development business. Many of us have been doing COTS software for a long time, and frankly, we did that intentionally because we didn't want to sign up for the support responsibilities of custom-written code. The pendulum is swinging back. If you're going to be truly cloud-based, you're going to be truly data and digitally driven, you're going to have to write a lot of your own code, especially if you're going to take advantage of a platform like AWS, GCP, or Azure. COTS software doesn't really tap into their capabilities. The applications that are developed leveraging those capabilities is where you get the real value. So you're in the application development business again, whether you like it or not, and start to get the collective heads wrapped around that fact. Another piece of advice I would give is plan for integration and plan for rapid change. We have a nice exhibition booth here. If you go to a session like RSA or something like that, it'll be much bigger. If you happen to be fortunate enough like me to sit on a couple of venture capital advisory firms, the amount of companies and the amount of solutions trying to address some of these problems is extraordinarily high. And it's only going to get higher. So thinking about how you're going to integrate all those solutions, all those data feeds together, which is exactly the kind of mentality that DAS has, is really, really important to think about that from a variability perspective and from an integration perspective. And I would think that you also have to plan for ramp up and ramp downs. And those of us who are used to signing, just a practical thing, those of us who are used to signing 3-year deals for some of these areas, it's probably not going to fly anymore because in a year, the whole landscape's going to be different. So again, make sure that you design for interoperability and plug and play there. So those would be the 3 ones that I could think of.
Thank you. So I don't know if there are any vendors here in the room, but from the vendor perspective, I think my advice is to have partners like Bob and Mike here that really help you shape the vision, which is very forward-looking. So thank you for that. We have a few minutes to take questions if there are in the crowd.
Oh, we got one here.
Open the mic. Open the mic. First of all, thanks for sharing your insights. My question is around auto remediation. For Bob, can you comment on that, and was there any success stories you can share with us, please?
On an automation perspective?
Auto remediation.
Auto remediation. We're not doing a ton with auto remediation. We're still, I'm going to say, in the fledgling stage there, where we can go out and have things that are self-corrected. We still, it's something we're investigating, but really we're taking baby steps in this process. We're going through and just doing what we can to remediate, and then if we can auto remediate, that's great. But it's something we still have to just get our arms around.
I will comment here from the perspective of all of our customers. So I think our advice is not to automatically change the code. In the product, we just recommend the code changes, so you can have one click to remediation. because nobody really wants to, override on for the developers. You want them to look at it. It's the middle in the middle. We save a lot of time in the process, but, the couple of minutes for somebody to check that that's that's a correct remediation, I think it's needed at that point. Maybe in the future, auto remediation would be more popular. Not
Right.
yet.
And just to add on top of that, I was thinking about auto remediation. Say you have a cloud security policy that says my S3 buckets must all be encrypted. All right, so I go to deploy a website and I have CloudFront. Okay, well, CloudFront can't read those can't read those KMS keys easily. I mean, you have to write some Lambda functions to do some crazy things and make that happen. But really, the intent is I've got a website that I want to deploy through CloudFront. It can't be encrypted. CloudFront can't read that. So either you have to have exception to your security policy, but if you auto remediate that, you're going to bring down some things and you're going to have some unhappy people.
Any more question or?
No, that's it. You're done.
You're done. Good.
But Merab, thank you for being there. I really appreciate you bringing Mike and Bob up there too. That was really insightful.
Thank you.
Thank you.
Thank you, everyone.
Thank you, everyone.
Thank you, everybody.
Thank you all. That was a very good session. Everyone was engaged. We're glad you were here for this, and now we are ready to move into our next session. There's going to be a 10-minute break, so go ahead, enjoy your 10 minutes, and move into your next breakout session.